Create a list with initial capacity in Python. Code like this often happens. This is really slow if you're about to append thousands of elements to your list, as the list will have to be constantly resized to fit the new elements. In Java, you can create an array list with an initial capacity. If you have some idea how big your list will be, this will be a lot more efficient. I understand that code like this can often be refactored into a list comprehension. If the for/while loop is very complicated, though, this is unfeasible. Is there an equivalent for us Python programmers?
Warning, this answer is contested. See comments. Results. Evaluate each function 144 times and average the duration. Conclusion. It barely matters. Premature optimization is the root of all evil.
Python lists have no built-in pre-allocation. If you really need to make a list, and need to avoid the overhead of appending, and you should verify that you do, you can do this. Perhaps you could avoid the list by using a generator instead. This way, the list isn't ever stored all in memory at all, merely generated as needed.
Short version, use. To pre-allocate a list, that is, to be able to address size elements of the list instead of gradually forming the list by appending. This operation is very fast, even on big lists. Allocating new objects that will be later assigned to list elements will take much longer, and will be the bottleneck in your program, performance-wise. Long version. I think that initialization time should be taken into account. Since in Python everything is a reference, it doesn't matter whether you set each element into none, or some string, either way it's only a reference. Though it will take longer if you want to create a new object for each element to reference. For Python 3.2, evaluation. As you can see, just making a big list of references to the same none object takes very little time. Prepending or extending takes longer. I didn't average anything, but after running this a few times I can tell you that extending and appending take roughly the same time. Allocating new object for each element, that is what takes the most time. And s.lots answer does that, formats a new string every time. Which is not strictly required. If you want to pre-allocate some space, just make a list of none, then assign data to list elements at will. Either way, it takes more time to generate data than to append/extend a list, whether you generate it while creating the list, or after that. But if you want a sparsely populated list, then starting with a list of none is definitely faster.
The Pythonic way for this is, or whatever default value you wish to pre-populate with, for example, caveat emptor, the beer 99 syntax creates one beer and then populates an array with 99 references to the same single instance. Python's default approach can be pretty efficient, although that efficiency decays as you increase the number of elements. Compare. With. On my Windows 7 Core i7, 64-bit Python gives. While C++ gives, built with Microsoft Visual C++, 64-bit, optimizations enabled. C++ debugged build produces. The point here is that with Python you can achieve a 7 to 8% performance improvement, and if you think you're writing a high-performance application, or if you're writing something that is used in a web service or something, then that isn't to be sniffed at, but you may need to rethink your choice of language. Also, the Python code here isn't really Python code. Switching to truly Python-esque code here gives better performance. Which gives. In 32-bit, doGenerator does better than doAllocate. Here the gap between doAppend and doAllocate is significantly larger. Obviously, The differences here really only apply if you are doing this more than a handful of times, or if you are doing this on a heavily loaded system where those numbers are going to get scaled out by orders of magnitude, or if you are dealing with considerably larger lists. The point here, do it the Pythonic way for the best performance. But if you are worrying about general, high-level performance, Python is the wrong language. The most fundamental problem being that Python function calls has traditionally been up to 300x slower than other languages due to Python features like decorators, etc. Python speed/performance dips, data aggregation,